There are a litany of blogs and articles across the internet touting the benefits of apple cider vinegar. From weight loss to lowering cholesterol, apple cider vinegar has been praised for its wide range of healthy benefits. But does it really provide these benefits? And how much of this is anecdotal and/or wives' tales, and how much of it has been tested by science? What's more, could you potentially cause yourself harm from drinking apple cider vinegar? We look to science. Hey there, my name is Andrew Pafford, and I'm a health and wellness professional with over a decade of experience helping Olympic-level athletes, desk jockeys, and seniors achieving their goals and improving their quality of life. Our goal with Primity is to find simple, at-home techniques and strategies rooted in science to help you with your health-related goals. Our information is meant to be descriptive, not prescriptive. We will always recommend that you talk to your appropriate health professional before making any serious changes to your routines. As we typically are wont to do at Primity, we need to start at the beginning. What is apple cider vinegar? Apple cider vinegar is produced through fermentation. The process is actually so simple, you could make your own apple cider vinegar from nothing more than some apple scraps, water, and some sugar. Most of our foods already contain the bacteria and yeast that would thrive on them. This is partially the reason why food tends to spoil so quickly. These microbes are able to set to work once our preserving methods get out of the way. That said, you can make your own apple cider vinegar simply by placing apple scraps in a jar, anything from cores, peels, leftover slices from wasteful children who don't finish their food, filling that jar with water, adding 1 tablespoon of sugar per cup of water used, and then placing a cheesecloth or breathable material over the opening, so no bugs, thank you, and letting it sit for about 4 weeks or so. During that time, the bacteria and yeast that exist on the apples will set to work, having been given an ideal environment, and will begin to ferment the apple scraps. As the yeast feast on the sugar, they produce alcohol, so think apple cider. But then, the acetic bacteria that are also present turns the alcohol byproduct into acetic acid, thus transforming the cider into vinegar. You can visibly see this process occurring in the jar. After a day or two, you'll notice little air bubbles forming around the apple pieces. This is the microbes releasing gas as a byproduct of processing the sugars and alcohol. After a couple more days, you'll notice the water becoming cloudier. This is the accumulation of acetic acid. In its current form, apple cider vinegar is predominantly used for culinary purposes. Its high acidic content lends itself to foods such as salad dressings and other dishes needing that nice acid bite. However, as the Romans observed, acidic foods tend to aid in the digestion of foods. Hence, balsamic vinaigrette and limoncello became popular cultural dishes. Only they had grapes and lemons on hand, not apples, but the same process to make them. So now that we've covered the basics, let's get to brass tacks about apple cider vinegar. Claim number 1. Apple cider vinegar helps lower blood lipids. We were able to find one study that performed a randomized control trial on 44 participants who were classified as being overweight with BMIs in a range of 27 to 40. Now, as an aside, I know BMI is not the greatest tool for measuring, but every experiment always has room for improvement, right? Now, both groups were placed on a restricted calorie diet. However, the experimental group received 30 milliliters a day of apple cider vinegar, while the control group only went on a reduced calorie diet, and the experiment was run for 12 weeks. At the end of the 12 weeks, blood was drawn and compared to baseline draws, and a number of stark differences were observed. In this particular study, because both groups were placed on a reduced calorie diet, it was hard to discern apple cider vinegar's direct effect on weight loss. Both groups showed loss with no discernible difference. So whether you were reducing your calories or reducing your calories plus the vinegar, they both lost about the same. We don't know if they would have lost weight by only consuming vinegar. I suspect not, though. The blood lipid panel, however, produced a number of interesting findings. At the end of the 12-week study, the control group's triglycerides increased by an average of 45 milligrams per deciliter, while the apple cider vinegar group decreased by an average of 58 milligrams per deciliter. Further, the HDL of the apple cider vinegar group increased on average by 3 milligrams per deciliter, while the control group showed very little change. So after 12 weeks, it would appear that there were a couple points of data that could be classified as statistically significant changes in the blood lipid panel in the apple cider vinegar group compared to the control group. This would seem to show that consuming approximately 30 milliliters of apple cider vinegar a day could have beneficial effects on blood lipid levels. Now, before we move away from the study, there was another significant piece of information that was gleaned from this data. The authors also performed what is known as a SNAQ score, or SNAQ, short for a Simplified Nutritional Appetite Questionnaire. Ultimately, the scores indicate participants' perception of hunger and satiety. Scores between 4 and 14 indicate a lower or suppressed diet, while scores of 15 to 20 indicate a normal diet. The control group expressed almost a half a point loss in appetite from baseline to conclusion. However, the apple cider vinegar group dropped a point and a half. Now, this may not seem like much. However, on a scale of 4 to 20, that's a pretty big jump. This may also lead to some mechanistic explanations into claim number 2. Apple cider vinegar helps you lose weight. Currently, there is very little data with conclusive results that apple cider vinegar alone makes you lose weight. However, there does exist data that can explain some probable mechanisms through which it can have a weight loss effect to achieve this outcome. The acetic acid we discussed earlier as the byproduct of the fermentation process is where the connections are likely to be found. When we think of acid, we typically don't think of fat. In reality, fats contain fatty acids and are classified into short, medium, or long-chain fatty acids depending on their makeup. Well, acetate is what is called a short-chain fatty acid. The only difference between acetate and acetic acid is whether a hydrogen has been plucked off or not. This is important because short-chain fatty acids are easily absorbed by the gut and play a huge role in our metabolic pathways and hormone regulation. At this point, I'll warn you there's a little bit of biology and chemistry ahead of us. I'm naming specific components in order to provide specific scientific mechanisms for those that are curious, but I'll double back and try to repackage what we've discussed into something a bit easier to swallow. So, short-chain fatty acids can increase the secretion of a hormone called leptin through the activation of free fatty acid receptors, specifically free fatty acid receptor 2, which are a type of receptor typically found in many mammalian cell membranes. More on this later. Leptin is an important hormone as it helps to directly regulate appetite. The body typically works in what can be described as a push-pull fashion, meaning if one hormone works to upregulate something, then another hormone usually exists as its opposite to downregulate the same thing. And thus, these hormones are then used in concert to help maintain a balance, such as insulin and glucagon to control blood sugar. In this case, ghrelin is a hormone that makes you hungry, whereas leptin is a hormone that makes you feel full or satiated. So to bring it home, we now have one direct mechanism through which apple cider vinegar can technically help you lose weight, at least to help curb your appetite and thus hopefully consume fewer calories. The acetic acid in vinegar is readily absorbed across the gut, and as acetic acid is a short-chain fatty acid, it can bind to the free fatty acid receptors on the surface of cells, specifically white adipocytes. Adipocytes or adipocytes are your common fat cell and are usually responsible for producing leptin. In a perfect system, as white adipocyte numbers increase through lipogenesis, or in layman's terms, as you begin to accrue fat, those same fat cells are supposed to produce leptin and tell the body, we have enough energy stored, let's stop eating so we don't get too fat. In this case, This seems to be the mechanism through which the short-chain fatty acid acetate can stimulate the release of leptin to suppress hunger. This seems to provide a valid mechanistic explanation as to why, in the fat loss study cited earlier, the group that consumed apple cider vinegar had drastically lower SNAC scores than the control group. What's more, acetate can further regulate blood glucose by improving its uptake into cells, specifically muscles. Keep in mind, anything that uses sugar from the bloodstream can play a role in stabilizing or destabilizing blood sugar. Most of our culture is concerned with insulin and insulin sensitivity because of the prevalence of diabetes. However, our muscles utilizing glucose for their functioning can help regulate blood sugar as well. Short-chain fatty acids bind to free fatty acid receptor 3, which stimulates a hormone release from the intestines called peptide YY, or PYY. PYY has been shown to increase the uptake of glucose into the muscles and fat cells for utilization, meaning short-chain fatty acids have a mechanistic pathway to affect blood glucose. Additionally, PYY is released from the gut to also influence appetite. And since PYY is shown to have increased secretion in the presence of short-chain fatty acids, we have yet another mechanistic pathway that apple cider vinegar can help with weight loss. In the article linked in the show notes, they reference a study in which participants were given PYY intravenously and a group that was given just a saline IV before hitting up a buffet. So one group was given a drip of PYY for about 90 minutes, and another group was just saline, salt water. Basically, it was a placebo. They didn't want the participants to know who was getting what, so they both got something. This was pre-hitting up your local buffet. Everyone in the PYY group ate approximately 1/3 less the amount of food than the saline group. Because of the feelings of satiety that PYY elicited, this seems to prove a powerful effect in reducing calorie consumption, and thus helping participants manage calorie consumption and achieve weight loss. While exciting and fascinating information about nutrition and weight loss is fun, we need to continue on our path exploring rumors about apple cider vinegar, and so on to claim number 3. Apple cider vinegar helps with arthritis. Fortunately, we were able to stumble upon the answer to this in the same article discussing the short-chain fatty acids and the free fatty acid receptors. In that article, they cited a study in which scientists knocked out the gene that allowed the expression of free fatty acid receptor 2 in mice. Put another way, they were able to make mice who had no free fatty acid receptor 2s on any of the cells in that mouse. This resulted in the mice having unresolved colitis, arthritis, and asthma. And since all of those conditions are inflammation in various regions of the body, the colon, the joints, and the lungs, respectively, we can say that yes, free fatty acid receptor 2 plays a role in inflammation management. And since short-chain fatty acids bind to free fatty acid receptor 2, and acetate is a short-chain fatty acid, then yes, it would seem that the acetic acid in apple cider vinegar plays a role in inflammation management. Now, I'm trying to make the distinction that this is specifically the acetic acid or acetate that confers these benefits and not some other magical compound in apple cider vinegar. The reason being is that apple cider vinegar is not the only source of acetic acid. Acetic acid, as we stated, is a byproduct of microbes feasting on alcohol and the sugars. This is important because this is the exact same interaction our gut flora have with fiber within our own GI tract, meaning the fiber that we've eaten. Yes, this is likely one of the driving factors why so many things seem to be linked to gut flora and fiber these days. It's the fact that these bacteria thrive on fibrous foods, because that's their food. And we thrive on short-chain fatty acids, which just so happens to be their poop, their metabolic byproduct. So we'll call it leftovers. So it would seem that we are wired to thrive on this symbiotic relationship based on the myriad of receptors and responses that occur with the short-chain fatty acids. I bring up this point now because I want to interject a cautionary note to these wonderful findings. Indeed, short-chain fatty acids, like what vinegars contain, impart a great deal of health benefits. However, remember, this process is supposed to be happening on the inside of our gut, where the environment is supposed to be nice and acidic. Where it is not acidic is in our mouths and throats. Yes, apple cider vinegar is very much an acid, and drinking a lot of acid, or modest amounts but in regular intervals, can indeed lead to bad things happening to those parts of our bodies. Consuming large or frequent quantities of acids have been shown to leach calcium from our bones and teeth, and there have been case studies of individuals consuming too much apple cider vinegar specifically that led to throat damage and other serious conditions like metabolic acidosis. This is very much a reminder that the dose makes the poison. A little apple cider vinegar can provide some benefits, but having a tall glass or even consuming respectable amounts on the regular could cause serious damage. And I wanted to drive the point home that it is the acetate providing the benefit, and we are supposed to be getting acetate from our own healthy gut flora and diet with plenty of fiber. These two things would seemingly confer the same benefits without the risk of possible throat and mouth damage. With that said, there is one other claim about apple cider vinegar that we need to look into, and that is claim number 4. Apple cider vinegar helps you fight sickness. For starters, the article studying the free fatty acid receptors cites how a number of immune cells have free fatty acid receptors on those cells, meaning they can be directly impacted by short-chain fatty acids. Further, one study looked at the direct impact of apple cider vinegar as an antimicrobial and antifungal, with no immune cells assisting. The 3 contestants it was going to bat against was E. coli, the fun bacteria that processes your poop, but sometimes finds its way back into your small intestines causing SIBO, Staphylococcus aureus, the golden bacteria that gives hospitals headaches because of how quickly it develops resistance to drug treatments, and C. albicans, a fungus that has been known to create certain problems in humans that we'll touch on a little later. All 3 of these can actually be found in a normal human microbiome, but can wreak havoc if they were to get out of their cage, so to speak. In the study, the researchers placed dots of varying concentrations of apple cider vinegar in petri dishes, 1 dish for each of the microbial cultures. Starting with a neat or undiluted apple cider vinegar concentration of 5% acidity, and then measuring dilutions to 1/2, 1/10, and 1/25 of apple cider vinegar. All 3 microbes were greatly inhibited near the neat apple cider vinegar concentrations. E. coli inhibition was reduced as the concentration was reduced, and Staph aureus was not even inhibited after half of the dilution, and C. albicans was only affected by the neat concentration. This study was done to help simulate the effect of taking apple cider vinegar on the gut, where these 3 microbes frequently exist. It should be noted, however, that this study was done in vitro and not in vivo, meaning it was done with live cells in a petri dish, but not within a live organism. Without all the fun, extenuating circumstances that come with a live gut, it's hard to say if drinking apple cider vinegar would have similar effects. But without confounding factors, it appears that it indeed does have antimicrobial and antifungal properties. Now, I left one loose thread about C. albicans, or Candida albicans, that we need to address. As stated earlier, C. albicans is a fungus. When it appears elsewhere than the gut, it has 2 favorite places that it likes to go: the mouth, because it's nice and moist, and the genitals of females, because it's nice and moist. For the mouth, that makes it a pretty easy target to try ripping a shot or two of apple cider vinegar to see if your symptoms improve. Again, remember the dose makes the poison, so don't wear a hole in your throat or eat away your teeth so that you end up creating one demon while trying to address another. However, the data shows that there could be some fortune in using apple cider vinegar in the instance of a C. albicans oral infection. Given how in the in vitro study it was able to repel the fungus at normal concentrations, it's not a far reach to suspect that apple cider vinegar could be helpful for combating an oral infection. Now, saying the same for a vaginal infection is a bit tougher, with potentially more costly repercussions. While the data does seem to be promising, there are a myriad of other factors that could cause complications by applying apple cider vinegar to the vaginal area. That being said, we were able to unearth one case study of someone who indeed did this and walked away with positive results. They were unresponsive to many antifungal treatments, and a last-ditch effort used an apple cider vinegar application to clean the area, and within days, it was able to resolve itself. Now again, I am not a physician, and I do not recommend taking any unusual course of action without consulting your OBGYN or appropriate doctor first. That said, with the data provided today, it would be worthwhile to bring to your doctor and have those discussions to see if something as simple as a common kitchen ingredient could have some efficacy. Well, today was a fascinating dive into researching the lore of apple cider vinegar. While it would appear that many of the myths are indeed true, at its heart, we've actually learned that many of the benefits that apple cider vinegar provides can actually be garnered from a diet rich in fiber and a healthy gut microbiome. Almost all of the benefits can be explained by acetate and how the body is receptive to those short-chain fatty acids. As such, I think here's a good point for us to review everything that we've covered today. Apple cider vinegar is made through a simple fermentation process that anyone can do at home. The main product of that fermentation process is acetic acid, which is easily absorbed by the gut and used as acetate. Our normal, healthy gut microbes create acetate as a byproduct when they feed on the fiber in our diet. Apple cider vinegar seems to improve blood lipid markers, especially HDL and triglycerides, likely because of the short-chain fatty acids like acetate. Apple cider vinegar can also be used to suppress appetite by increasing leptin secretion. Acetate binds to free fatty acid receptors on cells, which stimulates the production of leptin, a hormone that increases satiety. Short-chain fatty acids also stimulate the release of PYY in the gut, which also increases satiety. Free fatty acid receptors, and thus acetate, have a role in inflammation management. Mice who were bred with no free fatty acid receptors had rampant colitis, arthritis, and asthma, so acetate can likely curb those conditions by binding to free fatty acid receptors. Apple cider vinegar has caused damage to those consuming in large quantities, including enamel erosion, esophageal damage, and metabolic acidosis. Apple cider vinegar has been shown to be effective at suppressing microbial and fungal growth, and it may have potential to be used to treat certain types of fungal infections. The biggest takeaway from today, for me at least, was the power of short-chain fatty acids. All vinegars, not just apple cider vinegar, are composed of these short-chain fatty acids, and what's more, I learned that our gut microbes produce short-chain fatty acids from fiber. For the longest time, we've been told that we need to have a diet high in fiber, but it never made much sense why something that we could not digest could be so good for us. Now, with the explanation that it's food for our microbes, and we effectively get rewarded with short-chain fatty acids from feeding them, and that we have receptors specifically designed to respond to short-chain fatty acids, things seem so much more clear. It also drives home the importance of having a healthy gut microbiome and provides more mechanistic pathways of how those gut microbes work for us. Very truly an insightful episode, for me at least. That's it for today's episode on apple cider vinegar. If you found this information helpful, please subscribe to our podcast so you can be notified when new episodes arrive. You can also find us on YouTube podcasts. We're always curious to see what you're curious about, so send us your questions, comments, and feedback to info@primity.org. And as always, strength comes in many forms, from within and without. So be strong to be useful. Take care, everyone, and stay strong.